Okay, so this is going to be video 1 on doing solubility calculations. And the first type is where I ask you for the KSP. And the second type that I'll do in a separate video is when I ask you for the solubility. So first you have to figure out what I'm asking you for before you can determine what kind of calculation it is. And so when you do this calculation, it says, what is the solubility of calcium hydroxide at 60 degrees Celsius? So you are going to need some other information. In fact, you have to look it up on this chart here. And here's 60 degrees. And here's calcium hydroxide is right here. So it's 0.121 grams in 100 grams of water. So the solubility is 0.120 grams in 100 grams of H2O. So I'm going to start with that information. So I'm going to start with that I have 0.121 grams CaOH2. And as you can see over here, I've started getting my molar masses together. And so I'm going to calculate my molar mass. And it's going to be 40.028 plus 16 times 2 plus 1.008 times 2 equals 74.044. So 74.044 grams of calcium hydroxide for 1 mole of calcium hydroxide. And this many grams dissolve in 100 grams of H2O. And so we know by definition that 1 gram of H2O is equal to 1 milliliter of H2O. And we know that in there are 1,000 milliliters in 1 liter. And I want to get this to come out molarity, which is moles divided by liters. And so milliliters cancel with milliliters, grams cancel with grams, and grams cancel with grams. And so I'm left with moles per liter, which is exactly what I want. So I'm going to take 0.121 divided by my molar mass, and then I'm going to also divide by 100, and I'm going to multiply by 1,000, and I get that the solubility is 0.0163 moles per liter. So when I write my solubility expression, calcium hydroxide is a solid, and it dissociates, and then S, dissociates and gives me calcium ions plus 2 hydroxide ions. And originally I have 0 here, 0 here, 0 here. I'm not concerned with calcium hydroxide because solids do not appear in my KSP expression. But I know I'm going to lose X here, I'm going to gain X here, and I'm going to gain 2X here, because for every 1 calcium ion in solution, 2 hydroxide ions go into solution. So this is going to be X and 2X. KSP is going to equal concentration of calcium ions times the concentration of hydroxide ions squared, because we get 2. The stoichiometry says 2. And so it's going to be 0.0163 molar times 2 times 0.0163 molar squared. So then when I do this math, I get that answer times second answer again times, oh wait, let me clear this. I don't want to do it that way. So I'm going to take 0.0163 times 2 equals. Now I'm going to square that answer. Oh, I'm going to take second answer squared equals, and then I need to multiply that by 0.0163 equals, and I get 1.73 times 10 to the negative fifth is the KSP for calcium hydroxide at 60 degrees Celsius. Okay, so I will have another video for the other question I can ask you in just a minute.